For our next presentation, we have Hanwen discussing how to build a credit computation network with aggregated identities. Hanwen?
Hi, Bill. Okay, so today I'm going to share my experience on building a credit computation network with the aggregated identities. Of course, it's built on Substrate framework. And for the context, I'm the founder of Litentry and also the previous software engineer of Parity technologies. Let's take a look at the current blockchain industry and see why we raised the idea of the aggregated identity. So firstly, the Polkadot and Kusama has made a great practice of using on-chain governance, for example, runtime upgrade, treasury handling. But in the on-chain governance, we need more identity information for governance, participants, for transparency and interaction. And secondly, the growth of on-chain data are scattered in the different blockchains. As we see more blockchains here, and the new blockchains are coming like every month, right? There's indeed a lot of information. For example, a user could have NFTs on Binance Smart Chain, have been a liquidity provider on Uniswap, and attend a crowd loan in Kusama Persian auction. And next is KYC alternatives. As compliance regulation becomes more strict, KYC is prosecuted almost everywhere, and it is used to prevent DOT and harmful activities. But does the tedious KYC process the only solution? Actually, we are looking for the alternatives. The last but not least, as we see that Polkadot has its identity palette, and also Ethereum have ENS, Ethereum Name Services. Do we need to input the same information on different blockchains? Repeatedly? Probably we need a one-stop identity solution in the cross-chain scenarios. And to solve these problems, Litentry proposed an idea of an aggregated identity, which is to link the identities you have into one and link the relationship. This linking relationship is actually stored in an on-chain TE environment. This could provide the following benefits for the Web3 users and also to solve the previous problem. So functionally, it provides the interoperability from one blockchain to another. User could also use one blockchain signers to log into the other blockchain platforms and use the linked proxy accounts to make a payment cross-chain. And also financially, as an aggregated identity provides more info, it could be used as a KYC alternatives for IDO platforms, for airdrop activities, and to prevent the bots, right? And this is the, this is the aggregated identity is used as a KYC alternative. And socially, the aggregated identity could facilitate a better on-chain governance with a more complex profile, and further encourage users who has the similar interest to form a DAO. And last but not least, psychologically, the user, we also provide the dedicated privacy control for this aggregated identity, and it is the aggregated identity itself is also a self-sovereign identity. It is better than the other tools which make all the user information public. And but building a aggregated identity is not an easy job. Not to mention to bring the credit and reputation into the Web3 space. That's why we spend a lot of energy to get great team members. As a result, we have already created some good product, and at the same time, we also developing different products to support this idea, this aggregated identity. And our products could be further used for a credit computation. Here we have some example here. So firstly, we have this identity-based push notification, which could enable users to subscribe to some governance activities and also to subscribe to other identities like council members' wallet address. Sorry for the council members here. And we also have identity profiling services, which could analyze the user behavior with any input address. So I will explain this later. And the single sign-on, and the third is single sign-on, and the interaction with OAuth. This will gain the adoption of Web3 identities into Web2 platforms. I have just submit a Web3 grant application today to the Web3 Foundation about this. And the privacy preserving technologies, which is used to protect the user wallet information, we are building because we are, we are building a sidechain with TE devices to store the sensitive information of the users. And all this leads to the adoption of the aggregated identity. And yeah, there's already lots of tasks to be done here. And fortunately, we have the substrate framework, which could help us and let us to only focus on the identity-related issue on chain. And yeah, though this is not the main topic of this presentation, but let me have a brief introduction on how we build such an aggregated identity. We also use Substrate to do that. The rough idea is that we assign a challenger to a user who wants to link identity into another network. And then this user, for example, like Solana or Ethereum, then the user needs to sign this message and submit like the signature in the network. And in our off-chain network, our off-chain worker will then fetch the transaction and validate the proof in the transaction. So if you have already registered a identity in the with the identity registrar on Polkadot and Kusama, this may sound familiar to you because the logic is similar. But our approach is validate the proof on chain. So and also the identity is encrypted, and so no one can see it. It's protected in the TE devices, so no one can see it. I will explain this later as well. And now we have the aggregated identity, but is that enough to provide the background information for this, like ideal for airdrop or for device services? No, it's not, because the identity linking information are encrypted in the TE devices, so no other parties could access to it. Even for the owner, they could not get the linking information. So the outside world does not know that you are who you are, or if you are the targeted user, if you are, for example, a active governance participant, they do have no idea. So we need a place actually to generate a proof for the in a decentralized way. This is what the Litentry network. This is where the Litentry network comes in. And the network mainly includes 3 different layers. The first one is the data source layer, and second one is address analysis layer, and third one is identity aggregation layer. So let's take a look one by one. Firstly, we have the data source layer. This is very straightforward. The layer is provided by various Web3 data services on different blockchains. Just a second. Yeah, okay. Like Polkascan, Subscan, or Etherscan, we need to gather the raw block information and to index the data by the wallet address, like the governance activities, IDO activities, and the access info like non-fungible token or fungible token, right? So this is very straightforward. But at the same time, we are also building our own data indexer to help index this data. Then let's move to the second layer, which is the address analysis layer. The data this raw data are fed into the address analysis layer. There are different data analyzers who provide the computed high-level wallet information here in this layer. For example, this is our front-end UI of one of our data analyzer, which could calculate the label for a wallet as a strongholder, for example, as the high active user, or as a smart money user. Yeah. So in Kusama, we also generated the related score according to users' crowd loan activities and nominating activities. We also have analyzed some DeFi services, some DeFi activities on the Parity chain, for example, on Karura and on Moon River. We also cooperated with some ideal projects to help them to find targeted user and to prevent the bot to get the allocations. For example, we cooperated with Ranger protocol to do this. And the criteria the criteria here and the label specified, and the label are specified in the smart contract. And actually, we encouraging everyone to set up such a data analyzer. The Litentry network will curate the results from different analyzers here. And finally, we come into our identity aggregation layer. Our network built with Substrate will generate a credit proof with the information get from the address analysis layer. So here's a flow. Firstly, a user send a credit computation request to the network, and this request is actually encrypted by a sharding key. The sharding key is provided by the this TE sidechain. You can see the blue part on the side is our sidechain, and then this task will probably the picture is a little bit small, but I will explain. The task will this task firstly get into the green part. The green part is literally runtime, and then it will be distributed into the TE sidechain. Here, the TE sidechain worker will firstly decrypt it, and then it will fetch the linking identity information from the encrypt to the on-chain storage. I mean, in the Litentry runtime, with this linking wallet information, it's the off-chain worker will get the related address information from the address analysis layer. For example, if I here I have my Litentry wallet address, and in the encrypted on-chain storage, will get my related, for example, Kusama or Polkadot and the Ethereum wallet information, and then in the TE sidechain, it will fetch all the wallet information from the address analysis layer, and then in the TE worker, it will assemble all these wallet information and create aggregated identity credit. As a consequence, the credit will be encrypted into a proof, and this proof will be sent back to the Litentry runtime, and the Litentry runtime will finally send it to the outside world as an event. So here we would like to give some more information about the sidechain. We actually collaborate with the Integrated TE team and use Substrate TE network, but not network, sorry, use Substrate TE framework to build such a sidechain. Generally speaking, it wrapped the required pallet under a security layer. The request sent to the sidechain are encrypted. All the storage and the execution cannot be seen by anyone, even by the TE device owner. So the sidechain the sidechain also communicates with the Litentry runtime. So actually, the Litentry runtime and the sidechain are strong connected by the light client, by the embedded light client. Also, as you can see, we have several different pallets in this identity aggregation layer. As we mentioned before, there's NFT pallet. The NFT pallet actually could reduce the unnecessary computing for the less frequently changed data, and also to improve the efficiency of the identity data query. Why it does this is because if some user, for example, for the less changed data, user could record this data as an NFT. So next time, the user do not need to send another computing request to the network, and it will cost some money. But instead, he will directly to query if user have such an NFT in his accounts. So later I will make the example. So, but you see here, this is a screenshot of a web app. We actually provide a platform for project to distribute it NFT as a label for qualified user, and user could claim NFT in our platform and even further merge in two different NFTs into one. So this is some interesting features we provide here. So make a very wide example. So combine like the Polkadot strongholder with a Kusama strongholder to these two labels, you can get a Substrate diamond hand, this NFT. So just for example. Remember in the data analyzer layer, we have different criteria. They are records in the smart contract, and for example, the data analyzer information the encrypted identity linking information are all stored here. And by using smart connection sharing, we also get one more benefit is that we could compose the identity scoring algorithm easily. For example, to compose like the two, for example, the requirement of two labels in Polkadot and Kusama to compose them together into one. Yeah, as supplements, we also build awesome front-end application to help people to interact with our runtime and their identities. For example, we built the MyCrypto profile to show user owns NFTs on social platform. We start with Twitter and Ethereum, but Kusama will follow up soon. And we also built the web application. I already showed the screenshot before, but the app application is still in development. The features are Identity Hub for user to manage its identities. And we also built an app for user to easily participate the governance with the mobile devices and get push notifications and enable user to interact with the identity related features. For example, you see on the screenshot, the user could register his identity, see the identity info here. It's now, the demo app works on both Polkadot and Kusama. It's still in development, but we are, gonna release it soon, I think. Yeah. So thanks to the Substrate framework, we create this credit computation network and realize the interoperability with the aggregated identity, and also we achieve the composability and help user to protect the privacy and use actually the Polkadot and Kusama to ensure the security for our blockchain. Yeah, that's pretty much of it. And thank you, everyone. And it's very happy to be here. And thank you, Bill. I think I will keep to answer the questions in the Discord channel. Right.
Yeah. So thank you, Hanwen. We have actually a couple questions I was hoping to ask you before you head off to the Discord channel.
Yeah, sure.
So first, and I think this was a little unclear. So is Litentry going to be planning to become a parachain along with the sidechain? So there'll be like a parachain with this runtime and then the sidechain?
Yes.
Okay.
So we will have our runtime as a parachain, and we also encouraging other people to contribute to this sidechain and to set up this sidechain. But because the sidechain is connected with the Litentry runtime with the Light client, so the security of the sidechain could also be ensured.
Okay, excellent. And you had mentioned, this is compatible. You can get information from Polkadot, Kusama, Ethereum. Are there other networks that you're looking into, or is that to adding, or are those the ones you're staying with for now?
Yeah, of course. For example, the identity linking pallets, we start with Bitcoin and also Ethereum. And because we are EVM compatible, so lots of blockchain could be aggregated here. For example, the Polygon, for example, Binance Smart Chain, it could also be aggregated here. But we are also exploring some new potentials like Solana, at the moment. Okay. Oh, wow. Excellent. So something you mentioned that I was really intrigued by was OAuth integration. I've never heard of a Web3 ID being able to go through OAuth, but I may just not be aware of them. Is this a first? I don't know actually. I checked some practice and some papers, but I didn't find there's something already done here, because the thing is that we use this OAuth and also enable to use it with the self-custody wallet. There's some platform that you can log into you can log in with your email, but finally you will the wallet will be hosted by the platform, but not hosted by you. It's not fully decentralized. So I think this is something I haven't seen in the industry before.
Okay, yeah, I'd never have either. I thought that was really interesting and a great bridge into sort of the traditional Web 2 world using Web 3 on top of it. So that's really exciting. So the last question we have from I think it's very cool. I have one more question from one of the audience members. So how could you give an example of how this can be used to help people avoid having their identity analyzed? Like how this can be used? Can you give an example of how it can be used to protect privacy?
Actually, we didn't protect the privacy, but there's several different products. For example, Nansen, they're already building something like the profiler or do analytics could analysis the wallet activities. But this also, as the address is public, everyone could analysis a single address, right? But no one have built, a profiler for aggregated identity. This is because, no one want to publish this information, and also we do not want to, against the Web3 spirit, like to publish, users this kind of information. But actually, we create a new use scenario that the user could benefit from it. Could get a complex profile, but still keeps this information. In privacy. Nobody could access this your wallet graph. Nobody could access they get the relationship between your wallet addresses. So we still in the Web3 space, but we create a new use scenarios to this is to say, but we didn't to leak user information to do things like this.
All right. Well, thank you very much, Hanwen. We appreciate your time, and this is very interesting talk. I certainly learned a lot.